Welcome back, everyone. I hope you've got lots of energy during your break so we can do some more calculations. So let's just get going, shall we? First question. A box, oopsie, maybe I should have a pen, of 200 kilograms is lifted to a height of 10 meters. And now there's two questions. The first one is, calculate the potential energy of the box. We're good with that. If the height of the box is now 20 meters, how does the potential energy of the box change? Well, let's start with the easy one. We have a box of mass 200 kilograms. They tell me that it's a height of 10 meters. They want the potential energy. We've done this lots now, so we can do this. So potential energy is mass times gravity times height. So we have 200 times 9,8 times 10. So we take 200 times 9.8 times 10. 19,600. I'm happy with that value because it's a big mass. Okay, 200 kilograms is heavy. So I expected a big potential energy here, okay? Second part of the question. They now tell you that it's lifted to a height of 20. And they want to know how the potential energy changes. Now, you've got to be careful. They haven't asked you what is the new potential. If they did that, then it's easy. We could just put everything into the equation, get an answer. They asked, how does it change? This is asking you, does the potential energy get bigger or smaller? And how much does it change by? What are they asking you to take into consideration? The fact that potential energy is directly proportional to height. It went from 10 meters to 20 meters. 20 is 2 times 10. So my height doubled. Okay, so height doubled. Because potential and height are directly proportional to each other, if the height doubled, my potential energy doubles. So my answer is this. The potential energy, and we write it out nicely, will double. Now, if you couldn't see that, you are welcome to work it out. But I won't accept that value that you work out as the answer, because you're not telling me how it changed, you're telling me what it changed to. So just be careful. How? Description. If they said, what is the new potential? Answer. Value. Okay. A girl of mass 55 kilograms climbs up a flight of stairs to get to her next lesson. She's at school, obviously. Calculate her potential energy at the top of the stairs. So this is a basic diagram of the stairs. They're saying the vertical height is 5.5 meters. Sounds quite high, but we'll go with it. And it's 15 meters at an angle. So when we look at this, we know mass is 55 kilograms. I'll talk about the heights in a second. We want potential. In order to work out potential, I need to know height. I've got two values. I've got a 5.5 and I've got a 15. When I look at potential energy, it's vertical height, perpendicular height. All right, so actually the height that's important is the 5.5. the 15 doesn't matter. It doesn't matter how many stairs she went up. It doesn't matter whether they were winding stairs. It makes no difference. All I'm concerned about is that from where she started to where she ended, that height was 5.5 meters. So here, I put 5.5. The distance, at 15 meters, we're going to consider later on in your curriculum, and we're going to look at what happens to energy because of that. But for now, we're not interested in that. We just want the vertical height. So, potential energy, mass, times gravity, times height, 55 times 9,8 times 5.5. So let's do this. So we've got 55 times 9.8 times 5.5, and we get 2,964.5. So let's write our answer down. Oh, maybe I should have a pen. There we go. 2,000, now I've forgotten the answer, 964.5 joules. Okay, I'm happy with that answer. It was 5.5 meters, not that high, 55 kilograms, not that heavy. I'm good with that answer. Next one. An athlete of mass 65 kilograms runs at a constant speed of 4. On this note, we're only going to be working with constant speeds when it comes to kinetic energy, okay, at this point. Because if the speed's changing, then his kinetic energy is constantly changing. So for now, we're just going to simplify it, all right? They ask for two things. Calculate his kinetic energy originally. Then they say if his speed halves, calculate his new kinetic energy. So let's start with the first one. Mass, 65 kilograms. Speed, 4 meters per second. Kinetic energy is a half mv squared. So it's a half times 65 times 4 squared. We absolutely need our calculators. So 0.5 times 65 times 4 squared, 520. That's okay, it's not a bad one. He wasn't growing that fast, he's not that heavy. I'm okay with that. Now they say his speed halves, and then they want you to calculate his new kinetic energy. This is different than the question we did earlier with the potential, because that question said, how does the potential change? Here, they want you to calculate his new kinetic energy. In other words, they want a value. So, his mass hasn't changed. His speed, though, is now half what it was. Now it's 2 meters per second. What I'm expecting is that his kinetic energy is going to be 4 times smaller. Okay, so let's see if that's right. EK is a half mv squared, so it's a half times 65 times 2 squared. Okay, now that answers the one we had last time, so it was 520. Let's just quickly put that there. I'm going to remind myself of that just now. And now we've got half times 65 times 2 squared, and we get 130. Now, I said to you that I expect that this must be 4 times smaller than my original. Let's see if that is what happened. So I'm going to go 520 divided by 130, and I get 4. You can see it's 4. So I got exactly what I was expecting. The velocity halved, and the kinetic energy became 4 times smaller, because kinetic energy, remember, is directly proportional to V squared. That square is very, 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 very important. Okay, so we've done lots today. Done different ways of us asking the questions. It's about reading, so remembering whether you need to do a calculation or do a explanation type question. As with everything, this is about practice, practice, practice. And we've run out of time. So that's all for today, and I will see you again next time.